It's been great catching up with people, our faces, and having a chat. I think that's one of the best things about these conferences is a networking. As John mentioned, I started with working on Jade at least in '92, worked on it for about 20 years and left. So while I was there, the main areas I was working on are the database engine and SDS that have been covered today. On my sojourn or sabbatical, been working on quite different things. Most recently, I was working in the cybersecurity domain, running big data analytics. We were basically ingesting logs from multiple network appliances and running analytics pipelines. The value proposition was to discover unknown unknowns. In other words, what you don't know, you don't know. Charlotte just talked about this morning our ongoing investment in the Jade platform together with new investment in machine learning area. So this is about connecting those things. Our data science team recently extracted data from a student management system and built a prediction model that was able to predict student sharing. So this is about connecting those things, how to make data from your Jade database available for running that type of analytics. And there's two parts to this, both parts were influenced by talks I've had with clients represented here. So let's start with some background. What type of analytics we're talking about. So this is Gartner's definition of advanced analytics that covers the what and the why. So, let's go back here. So it's basically tools that you typically wouldn't find in a standard business intelligence analytics suite. We're going to start off with structured data. So the type of tools we're talking about are machine learning algorithms, there's several of those, and various mathematical algorithms that don't fall into the ML category. The purpose or the why are to do things like make predictions, generate recommendations, discover deeper insight. Once you start going beyond structured data, there's text, and we've looked at things like that. So there's text mining, sentiment analysis, and the application of NLP, natural language processing, all of those things come into play. Right, I want to talk about the next bit first. So the next bit is, all of these things I'm going to present are stuff that you can do with Jade as it is now, current Jade releases. You don't have to wait for us to deliver new functionality. That's another key point I want to make. The first bit is about a type of data that we don't always save systems of record that are valued to all kinds of analytics, even LPI. And this is about how to capture that in a window of opportunity, catching it while you can. So this is stuff you know, but it's basically to set some background terminology. In accounting, we have recorded knowledge and derived knowledge. Accountants don't use erasers, or they go to jail. Credits and debits are recorded in a ledger. Trial balance is computed, the derived fact. If an error is detected, you're not allowed to go back and alter prior entries in your ledger. What you do instead is record a compensating entry that, when applied, reverses the mistake. Just the idea here is to think about those type of activities and how they're represented. In banking, the banks will record transactional activity against an account. If you want the current balance, it's computed by taking last month's total, applying the effects of the credits, debits, and any reversals to get the result. Other forms of activities in business systems are orders, sales, shipments, and so on. So the common characteristics of all of those types of things is that things that happen in a point of time. So So we have a timestamp and a description of the activity. Another common one that occurs on lots of systems is an application audit trail. So the audit record captures who did something, what they did, and when it happened. Are there any people here who maintain jetted systems? So I think what's the concept that we use for that in Jet that's inherited from Link for that type of activity?
The event.
It's an event. So that's the key point to keep in mind for the remainder of the talk. Just reflecting on the way they're maintained in a database. Generally, you write them once, read them many times, but never update them. At least the business fields, you may update status field. And yeah, so that'll do. The next point is what we do, how do we treat entities or things that are not obviously events. There's this pervasive notion of CRUD, create, read, update, delete. With CRUD, there's generally a single object in your database to represent the entity. So this life cycle of, let's say, a product through this CRUD cycle is, oops. So when it first enters the system, we create an instance in the database with all of its attributes, some ID fields, things about it. And then in your application, as you change it, in this example, we can see the chain ring. The only thing that's changing is the price. But although we have different versions of the product across time, in the database, we only have the latest version of the object. So just thinking about that, if we're selling this product, the sales of each product, at some point in time, you sold the product at that price, but since you've only got the latest, you've lost some information. So going back, say you asked the developer why they wrote it this way. An agile team, they'll say, I use the YAGNI principle. You ain't going to need it. The system does exactly what it's required and nothing more. So that's maybe okay. Let's look at why that might matter. Analytics scenario. So I'll hypothetical. Sue, the sales director, has noticed some sort of pattern between product pricing over time and sales volumes. You can see where this is going. I'll continue it. I'm explaining this because some colleagues of mine said it would be good to give an example. So anyway, she goes to Joe, her BI analyst, and says, can you do some digging? Can you tell me what the correlation is, sales and behavior of pricing in each month, so I can go to, work out what's going on back. So Joe does his first query about sales versus products and their volumes across months. Sure enough, he notices a trend. So sales for products A, B, and C are lowish in January, they're higher in May and down again in July. Whereas sales for products X, Y, and Z show quite a different pattern. So the next thing he needs to do is look for the pricing in each of those months. It doesn't take him long to realise he can't do it. It's obvious why. He can't, because we've only got the latest version of each product, and what's more, there's no timestamp. With this type of data, if you're doing this way, timestamp is not important, so it's optional because you only have the latest. So let's look first at an engineering solution of event sourcing. I knew you would try. Has anyone used it in a Jade system? Okay, not so many. That's the Martin. This is a design pattern popularized by Martin Fowler. That's his succinct definition. Let's illustrate this with the product example. So with event sourcing, instead of saving the latest state of product, we would save it, represent it or model it as a sequence of events that describe the state changes. With that, what it means is by processing that sequence, you can derive the latest version, which means that's the derived factor. So you've got the CRUD value, but you've got lots more too. You can now you can constitute or materialize the version of the product for every given sale. So you can answer that question, and you've got that full product pricing history. So that's a solution that's quite good if you're have that use case or building a new system. But if you thought you're going to retrofit that back to a legacy system and went to the business, they'd be thinking ROI and asking hard questions about cost of development and effects on the data platform. So let's look for a less intrusive method that requires no changes to business logic and no change to the platform. So this isn't my diagram, I borrowed it, but to illustrate the technique. So in the industry, there's something known as change data capture. Has anyone come across that too? Okay. There is a question for you on this. So there's various ways of doing this. One is by basic idea is to capture changes at the database level, more or less as they're happening, and put them away, save them somewhere. There's several approaches. One is polling the database. You can see that's going to miss things. There's using database triggers in relational. That adds a burden to the transaction processing. The other one is called log-based. You recognize this sort of stuff in Jade. So the way that works is there's a process called the capture process that is reading changes, creates updates and deletes saved in the database transaction log. In Jade, that's the journal. The capture process converts those to a representation that looks like create, update, delete, saves it in internal tables called CDC tables, and that's fed off to what's known as an extract, transform, load pipeline, or ETL for short, to feed a data warehouse. So, can anyone think of how you would do that in Jade? Jade, I know John knows. Craig as well, or Naked. Correct. Can he have a prize later? Oh, he knew it too. Of course you did. Good. So as I said, this is stuff you can do today. Right. Let's look at something you can do without writing any code. So if you're already using RPS, Relational Population Service, you're actually either there or almost there. So RPS has two update modes that you can set on your tables that were populated. One is the default overwrite mode. With that, we're basically maintaining only the latest version of each item, which means it's mimicking what that CRUD behavior had on your primary database. And that's not what we want to solve the Joe and Sue scenario. What we want to do is enable historical tables. Historical tables maintain all of that history. So you have a create, several updates, and a delete, which means even when the record's deleted on the primary database, you've still got that complete history, and it's up to you how long you keep it. Now this is normally, I know some people run cheap and cheerful stuff on top of RPS databases. It's really intended to be a staging database. Ask me afterwards why that's the case. But anyway, this is now the source of an ETL pipeline to your data warehouse. What's more, you can now wire up an ETL pipeline to something else, a platform suited to running this advanced analytics. Right. The next set, hopefully that's of some use to people. The next scenario was inspired by a talk I had with a client last year. In the wrap-up session, the client is actually represented here. The enterprise architect guy had to leave for an emergency, but I had a chat with him about it, and what I'm going to talk about is quite close to what they're doing. So in the talk, in the wrap-up section, the tech fellow guy drew some boxes on a whiteboard that illustrated sort of their direction, not something they're doing right now, but stuff they want to do. One of the boxes was labeled Kefka, the other one was data lake, and there was Jade in it. So my eyes lit up, because I think that's the sort of thing we can make Jade play very well with. So the next part is my extrapolation of what I think they were trying to do and why. It's probably wrong, but I think the elements are close enough. Right, so that's the next bit. So what are we trying to do? So here, we probably got a Jade database, that's why you're here, but you might be a company that's acquiring further products, either to fulfill functional business functional requirements or by company acquisition. So you've got Jade plus several other systems of record. Some of them they've got different databases. They could be SQL, Oracle, or something else. You've also got some sort of data warehouse. So the goal will be to collect data from multiple databases, integrate it into a warehouse for the purpose of running. This box is your standard BI stuff. So you want to run analytics, reporting, dashboards across data from multiple database sources. That's this angle. Now he also had a data lake, which told me they're going to go, that must be, a data lake is basically a staging or reservoir for collecting data, for generally on board. It's a source downstream analytics platform of some form. The basic idea is to capture data in something close to its natural format. See me afterward if you want to know more, because there's some pitfalls in this approach. Later on, you might be thinking of ingesting data from other things, mobile devices, IoT, sensor tooling, bringing in text and stuff, documents, So this thing is growing. You'd start off small with just a few things on here, a few data sources, and a couple of targets over here. Now, I hope some people are a bit disturbed by the number of arrows on here. Should be. There's basically an arrow for each combination of thing on the one for each kind of data source. To kind of data sync combination. And you can see that it's going to be some sort of combinatorial exploit. If someone had started on building something like this a few years ago, I think they'd still be working on it, or still building it. Probably wouldn't work very well, and it definitely won't scale. So let's look for something with a bit more order. So this diagram looks a bit better, fewer arrows. And what you can see, there's at most one arrow on the left per kind of thing, or kind of data source, going into this thing I've called an event bus in the middle, and there's at least one arrow for kind of data target on the right. So these are the two we've talked about. I just added those just to demonstrate this combination. Right. Now, the next bit is what we can plug in. So this event bus is basically saying, can we do this with some sort of event streaming paradigm? And you can, for sure. There's different sort of technologies we can plug in, so I'm going to select one for two reasons. One is that the client said that's what they're going to use. It's Kefka. The other one is I've had recent hands-on experience with it, using it in my sabbatical. Just before the wrap-up, I will show you an equivalent technology in a cloud managed service as your platform as service offering that has equivalent technology. So, next bit. So just a brief look at Kefka. It's originally developed by LinkedIn about 8 years ago. It was donated to the Apache Software Foundation. So it's now open source. A lot of big companies using it for event streaming and message queues, and that includes companies like Netflix, Twitter, Twitter, Spotify, Airbnb, to name a few. So it's an event streaming platform. The kind of API it exposes is a publisher-subscriber message queue, and it's implemented as a distributed commit log. The commit log is very similar to database transaction log. Before we go into how we might use that, just cover some of the main concepts in Kefka. So the first main abstraction is that of a topic. So the idea of a topic is mainly so you can group together related events. So partition is the unit of distribution, and it's used for two main purposes. For scale out, so each of these partitions can be located. You can have all of them on a single machine, or in a cluster environment containing multiple machines. These can be located across the cluster. So it's used for load balancing workload across lots of machines, or for replication. We have copies of the same partition on several machines. So if one goes down, you can continue processing because the information is still there. Next one is, this is all very simple. It's a keep it simple, stupid approach. So a petition is just a file fundamentally, and that is what makes it fast. Producers append records to the end. So it's just a log. You keep adding records to the end. Consumers read those sequentially, and they read from an offset. So the other key thing here is, I should mention, this is a multi-subscriber paradigm. So you can have 0, 1, or many subscribers. The 0 case really indicates that producers can be producing or publishing events to this with no consumers. Consumers can come and go. They can, as I said, they read from an offset. So typically they'd start from the beginning and keep reading till they reach the end, but they can go away, remember where they are, go away, come back and resume processing, or they can go back to the beginning, reprocess them and do something completely different. That's all.
That's probably
enough.
Let's take a look at this conceptual scenario.
This is my made-up conceptual architecture that's a projection of that whiteboard diagram with the boxes to show how Jade would play in this environment. So we have Jade as an event producer, publishing events to Jade topics in this event bus. Now we're thinking of Kefka. We have various consumers, and they're reading the events and pushing them out to our two targets, data warehouse and data lake. Now, that's all very well storing stuff, but you need to bring humans into the loop. We need a presentation or action layer, and this is just showing some of the use cases, so we can still, because we've got a warehouse, we can still run our BI tools, still relevant, but now we can bring in this advanced analytics platform that allows things like a data science team to train models and test them and even run analytics. One thing of note, typically in here, this is not something you'd expose to end users. It's usually specialists that can interpret the data. So someone who would be BI analyst, for example. Just want to have a quick look at what would be involved in putting this together. It's really an enabling thing as far as Jade goes. So it's this thing on the left called a Jade event producer. Now this bit, Craig knows we've already got that. That's how you read stuff from the journal. This is the thing we need, and it's using an existing API and some form of Kefka API to publish events to the topics. So that stuff you could build without any of our help, but we can probably provide help because so that's where we would like. We know there's at least one customer who's interested in this. If there's anyone else, we'd welcome you to contact your Jade representatives and start a conversation. This isn't something we're just going to build in Jade because we don't know what the requirements are. We'd rather have some sort of collaborative effort that we can work with the community on. Now, just to summarize the types of things we would need, the API. There's a lot of open, so Kefka itself has a lot of different language bindings for all the common languages. There isn't a Jade one yet. But there's someone's built a REST proxy, so that's already an option. If you can write a REST client in Jade, it can, be a client that's publishing events to REST. It can then use another API, forward it to Kefka. The other thing you would need to do, so these events another concept that I didn't mention earlier is that Kefka has a concept of a message, and that's the unit of data transfer. A message is really just a key value pair, each of which is just an opaque format. It's a byte array, so you can put anything you like in it, JSON or an actual binary representation. So what you want to do, of course, is decide on an interchange format that producers and consumers will both interpret. You need something to convert, what's known as a SERDES or serialized deserialization mechanism. That doesn't require Jade developers. Then there's the producers, which makes use of the existing API and the new Kefka API. Then there's the consumers themselves. Now this is outside of Jade, so this is opened up to a wider skill set. You don't need to rely on Jade development skills, which is a scarce resource. So the sort of things we can help you with, definitely with that part, and possibly with all the rest as well, at least on a consultancy basis. Next, another thing is establishing initial state. There's the old school way, which people use as a bulk extract from your source database and load to flat files and load them into the target. Why do it? Publishing them in the form of a create, followed by, then you continue with your incremental processing. It means that you're only dealing with one mechanism. Your consumers then just process the initial database creation, which is a snapshot point of time, and then continue it on with replaying the ongoing replication, incremental changes. Hope that makes sense. Sounds stupid, but it'll work. Anyway, I mentioned, you can see this isn't a slide I built. It's one presented by the program manager for Azure Event Hubs at Integrate 2017. So the interesting things here is Azure has this concept of event hubs, which is very close to Kefka. So it's an event streaming service based on a distributed commit log. It has a pub sub sort of paradigm, has petitions and topics that work exactly the same way as Kefka. Wonder where they got that idea from. Anyway, just last year they've also released what's called a Kefka endpoint, which is protocol compatible with Kefka. What that means is if you'd already written a Kefka client, it's able to work in this environment with no code changes. So you may have started off with an on-prem version using Kefka and so on. It gives you the option of migrating to a cloud-managed service. Or you might start off with that directly, write something targeted to the Event Hub API. The advantages of a platform like this is the usual managed service advantages. Someone else takes care of managing everything over here, and things go wrong, patching, software upgrades, backups and all that stuff. And also you don't need any on-premise big data specialists because someone else is handling scaling out and all that sort of stuff for you. Just so there's the opportunity for a Jade to play in this environment.
Just a quick walk through the possible data flows. So Jade's sitting up here publishing things to Event Hub. And now we've got this other layer that I didn't have.
It's a streaming layer.
What's happening here, these are special forms of what's called streaming analytics.
It can actually take a look
at just individual events or a batch of
events and run analytics. That sounds sort of dodgy, doesn't it? Because you've not got a lot of information, but there are analytics that you can just run on with a few events. But what also can happen is that there's more than that involved. So if someone's trained a model based on a huge amount of data first, so it's actually can be a combination of that model, the event, and an algorithm. So that's looking at things on the fly. Eventually they land in this long-term storage. And notice that in Azure have a data lake as well. And we've got this presentation action layer on the right. Again, we've got dashboards. And there's this platform. So Cortana is Microsoft's version of a platform for running machine learning. So this is where your data scientists could potentially operate, specialists. So this is all about opening Jade to this sort of advanced analytics. We've covered a couple of use cases, the catch it while you can one, how to integrate with this type of technology. So that's the end of my talk. Thank you for your attention, those that are still awake. And are there any questions? Hi.
Really to control the size of that event bus, like the things that's quite.
Yes.
Quite large.
Yep, very good question. So the way that works in Kefka is you define a retention period, which can be hours, days, weeks, months, or longer. And Kefka takes care of expunging expired data. So one thing it's efficient because they're just files, it just deletes them, so you don't have to worry about that. So it's configured. Good question. Any more questions?